Hello everyone, welcome back to the channel. In today's lesson, we are solving a problem on moment of a force. Question: a uniform rod 8 meters long, weighing 5 kilograms, is supported horizontally by two vertical parallel strings at P and Q and at distances of 2 meters and 6 meters from one end. Weight of 1 kilogram, 1.5 kilogram, and 2 kilogram are attached at distances of 1 meters, 5 meters, and 7 meters respectively from the same end. Find the tension in each vertical string. Let's understand the situation. We have a uniform rod, length 8 meters, mass 5 kilogram. The rod is held horizontally by two vertical parallel strings. One string at point P, which is 2 meters from one end, another string at point Q, which is 6 meters from the same end. 3 extra weights are attached to the rod: 1 kilogram at 1 meter, 1.5 kilogram at 5 meters, 2 kilogram at 7 meters. Our task is to find the tension in each vertical strings. Let's start by drawing the diagram. Draw a straight horizontal line to represent the rod. Label the total length as 8 meters. Since the rod is uniform, its weight acts at the center. The center is 4 meters from either end. Draw a downward arrow at the center and label it 5 kilogram. Now choose one end of the rod as the reference end. All distances will be measured from this same end. We are told from the question that one string is at point P, 2 meters from one end. In between this end and the middle is assumed to be 2 meters from the chosen end. Draw an upward arrow and label it P. We are also told that another string is at point Q, 6 meters from the same end. In between the middle and the other end is assumed to be 6 meters from the chosen end. Draw another upward arrow and label it Q. From the question, weight of 1 kilogram is attached at a distance of 1 meter, 1.5 kilogram at 5 meters, and 2 kilogram at 7 meters from the same end. In between 0 and 2 meters is 1 meter. At 1 meter, draw a downward arrow labeled 1 kilogram. In between 4 meters and 6 meters is 5 meters. At 5 meters, draw a downward arrow labeled 1.5 kilogram. Then in between 6 meters and 8 meters is 7 meters. At 7 meters, draw a downward arrow labeled 2 kilogram. This completes our diagram. Choosing a turning point. The rod can rotate about either P or Q. Let's choose point P as our turning point. This means any force acting at P has 0 moment. We only consider forces acting at a distance from P. Let's identify the moment about P. The clockwise moments about P are 1. Weight of the rod 5 kg, acting at 4 meters, which is at a distance of 2 meters from P. Moment is equal to 5 times 2. 2. Weight of 1.5 kg at 5 meters, which is 3 meters from P. Moment is equal to 1.5 times 3. 3. Weight of 2 kg at 7 meters, which is 5 meters from P. Moment is equal to 2 times 5. Total clockwise moment is 5 times 2 plus 1.5 times 3 plus 2 times 5. Anticlockwise moment about P. 1. Weight of 1 kg at 1 meter, which is 1 meter from P. Moment is equal to 1 times 1. 2. The tension Q at 6 meters, which is 4 meters from P. Moment is equal to Q times 4. Total anticlockwise moment is 1 times 1 plus 4Q. Applying the principle of moment since the rod is in equilibrium, total clockwise moment is equal to total anticlockwise moment. 5 times 2 plus 1.5 times 3 plus 2 times 5 is equal to 1 times 1 plus 4Q. Simplifying, 10 plus 4.5 plus 10 is equal to 1 plus 4Q. 24.5 minus 1 is equal to 4Q. 23.5 is equal to 4Q. Q is equal to 5.875 kilogram. Now we have to find the tension at P. For a body in equilibrium, total upward force is equal to total downward force. So total downward force are rod 5 kg, attached weight 1 plus 1.5 plus 2. So total downward force is equal to 9.5 kg. Total upward force is P plus Q. So total upward force is equal to total downward force, which is P plus Q is equal to 9.5. Substitute Q is equal to 5.875 kilogram. P plus 5.875 is equal to 9.5. P is equal to 9.5 minus 5.875. P is equal to 3.625 kilogram. Tension is in Newton. Converting to Newton, where G is equal to 10 meter per second square, Q is equal to 5.875 times 10, equal to 58.75 Newton. P is equal to 3.625 times 10, equal to 36.25 Newton. Final answer, tension at P is equal to 36.25 Newton. Tension at Q is equal to 58.75 Newton. That is it. If this explanation helped you, don't forget to like, share, and subscribe for more physics lessons. See you in the next class.